Well, welcome to our second monthly webinar in our Industrial Energy Management series. Today, we're going to be talking about utility bills and what we can learn and how to identify cost savings opportunities simply from what's on your bills. But we also encourage you to join us next month in March when we'll be talking about best practices and tools for conducting an internal energy assessment of your facility. Some of the recommendations on what to look for, what tools, free tools are out there for you to use to do those internal assessments. Well, let's go ahead and get started. So my name is Brian Rasmussen. I'm a professor here at Texas A&M University and the director of the Gulf Coast Center of Excellence. This is a Department of Energy center focused on supporting industrial energy and energy efficiency, as well as training of students throughout the Gulf Coast area. So as I mentioned, this webinar will review the essentials of how industrial and commercial facilities are charged for their energy usage, and as well as what are some cost-saving opportunities you should keep your eyes out for. So essentially, this seminar is going to be divided into two pieces. We're going to first talk about what you can learn from your utility bills, and then second, we'll talk about simple methods for reducing your utility costs. So let's first talk about how to understand your energy use. So we always recommend that you start with a review of your actual utility bills. So depending on how easy these are to come by, you may request copies of your bills from, say, corporate headquarters or your accounting office, and they may send you a spreadsheet that summarizes. What you want are the actual utility bills, because on those bills there will be a breakdown of how much you're being charged, not overall, but how much of your charges are coming from kilowatt hour usage versus peak demand kilowatt usage. And we'll talk about that in a moment, as well as what charges are independent of how much energy or power that you are using. We would encourage you to evaluate your utility bills with respect to weather, changing production levels, key equipment that you might be using. Don't forget to analyze not just electricity, but any natural gas, propane that you might be using, water, or even some of your waste streams. Now, we'll get into some of the tools that are available to help you do this in just a few minutes. But let's talk just briefly about electricity in particular. Electricity is generated by power plants or other groups that are known as resource entities. These operate typically by selling their energy on the wholesale market. And then they sell the energy on the wholesale market, but the electricity is then transmitted through service providers, through power lines and people that maintain those power lines, which eventually makes its way to consumers. The consumers, on the other hand, purchase electricity on the retail market, and then that market then recompenses both the transmission and distribution service providers, also sometimes known as TDSPs, as well as the resource entities that are generating the electricity. Now, this can get a little complicated depending on what state you're in because of how this buying and selling of electricity is regulated by the government or not regulated, as the case may be. Along with airlines and a few other things that were deregulated at the end of the 1900s, electricity was in the process of being deregulated across the country. And then with some high profile problems, some of those deregulation efforts stopped, or maybe are only part way in place. So for example, here in Texas, where I am, our generation is deregulated, meaning anybody can produce electricity as long as they meet certain criteria and sell it on the wholesale market, as well as selling electricity. Anybody can create a business out of their garage, buy electricity on the wholesale market, and then resell it to consumers according to whatever contract terms they wish, and hopefully making money in the process. However, the transmission of that electricity in Texas is regulated, and meaning that there is an entity, the Public Utility Commission, that dictates what are the rates for distributing electricity across the grid. So the end user, whether they know this or not, is paying both the people that generate the electricity as well as the people who are distributing the electricity. The only difference is one is governed by a market and one is governed by a regulation body. And as you can see, deregulation across the United States is in various forms for both the natural gas and the electricity industry. Now this is a little important because it comes into play on how you're billed for your electricity. Our current state-of-the-art electrical meters will measure electrical current and voltage to determine power, which we use either in units of kilowatts or kilovolt amps. This quantity is integrated over time to determine your usage, your kilowatt hour, or in other words, your energy, also sometimes called consumption. Smart meters measure and communicate the average power every 15 minutes. And so in other words, what's being communicated back to your provider is both the total kilowatt hours that you're using over the month, as well as your peak or average power draw, kilowatts, that you're using every 15 minutes during that month. So what this means is when you're charged for electricity, typically you would have a charge that's based on kilowatt hours, or the total amount of energy you've consumed during the month. This is how residential units are typically built. They're only billed for kilowatt hours. However, large entities, industrial and commercial buildings, are typically billed both on consumption, kilowatt hours, and their demand, in other words, their kilowatts or kilovolt amps. And that demand is typically uses the highest 15-minute demand over the whole month. So if you had one 15-minute period where you were using all the equipment in your facility, or you had a commercial building where all the air conditioning systems were turned on at the same time, that would probably dictate your peak value and what you're charged for that month. And for many consumers, industrial and commercial, their bills are approximately half and half, or maybe 60-40, between consumption and demand. And so it's not just about how much total energy you use, it also matters when you use it. Now, we should note here that in the Gulf Coast region in particular, electric rates may be dependent on a lot of things. You may be charged, of course, based on your kilowatt hours and your peak kilowatts for the month, but those rates may differ depending on the season. They may differ depending on the hour of the day, particularly on our coasts in California and New York. They have looked at time of use, where your rates may change with each hour of the day. And finally, some utilities utilize block energy pricing, particularly in areas like Louisiana along the Gulf Coast. And there they charge you a different dollars per kilowatt hour rate for the first block of energy you use during the month, and then the second block may be at a different rate. And then the size of the blocks is dictated by that peak 15-minute power that you hit during the month. So this gets fairly complicated, but what it really does is it hides how your peak 15-minute demand affects your charges. There is really a hidden penalty for demand built into block energy pricing. So let's talk about this a little more visually. So in a typical facility in a day, your electricity use may look something like this, with every 15 minutes measuring your electrical power. The area under this curve is your kilowatt hours, your electrical consumption that you pay for. And then they will look and find the peak 15 minutes, and that will dictate your peak demand charges, particularly for the whole month. Now, a few caveats here. One of the things you may need to do is dig into your contract, or what is known as your rate tariff or your rate schedule that is typically available from your provider, in which it will dictate every single charge and tell you exactly how how that charge is calculated. And you may see a few things in here. Here's some terminology that may be useful. NCP refers to non-coincident peak. It means the highest 15-minute power draw that you had at your site during the month. Then the 4CP or 4 coincident peak means what was your power draw when the grid hit its highest 15-minute average power draw during each quarter of the year. So some of these charges may be based on your site peak, and some charges may be based on the grid's peak. Most of the time, what we see is NCP charges, meaning your charges are based off of your peak, but you should be aware of these others. One other thing to be aware of is what's known as a ratchet clause. If one month you have a particularly high peak, and then the next month you have a particularly low peak demand, they still may charge you for a higher value, because in essence, they had to install power lines and transformers and things to be able to handle this larger demand. And so they're going to recoup their costs whether you use it every month or not. And so if you have a particularly bad month, it may not just be a penalty that month for your peak demand charges. You may get penalized for the next 12 months if in terms of what is a ratchet clause, because they're going to charge you for your actual peak or 80% of your highest peak in the last year, whichever is greater. And that percentage may vary from provider to provider, but it's typically around 80%. Finally, something that we'll talk about in a minute is a power factor penalty. So one thing to note is your particular demand costs may include some, all of these, or maybe just one, depending on your contract and your provider. So we like to analyze how facilities are using power, because it helps us understand how to save them in their costs, even if we aren't saving them any energy. Now, one thing you can do is you can request your 15-minute demand data from your electrical provider. They'll either provide it for you in a large comma delimited file, or they'll point you to an online portal where you can download it yourself. But in essence, this is giving you that 15-minute power data that's being communicated from your smart meter. But even if you don't have access to that 15-minute data, you can extract quite a bit of information just from your monthly utility bills. And I'd like to show you an example of that. So let's assume that in a particular month, you've got a bill, and on that bill, it will say your kilowatt hour usage for that month, which we're going to call A. It'll also list your peak demand or your peak kilowatts for the month. And we're going to look at the area under that number for the entire billing period and call that area B. If you look at the ratio of A to B, we could call that the electrical load factor. In other words, it measures whether you are fairly consistent with your electricity use over time, or if you have large peaks over time. So in other words, the electrical load factor always will be between 0 and 1, and a high electrical load factor indicates a plant that either is operating 23 or 24 hours a day, or a plant that is leaving on a lot of equipment on during the nighttime or non-production hours when they don't need to. A low electrical load factor indicates a plant that may have either low operating hours, or they have problems with large spikes in peak demand. So the electrical load factor by itself gives us a hint of what's going on, but if we really want to pin down exactly what's going on, we need a second piece of information. And that comes in the form of the plant's operating hours. So again, we look at our utility bill and look at our total kilowatt hours, and then we look at the production schedule, or for a commercial building, these are the operating hours of the commercial building. And we look at now the area under the curve using again our peak demand number but only looking at the area that's defined by our operating schedule. And we look at the ratio of A to C. In this, what this gives us, it gives us what we call the production load factor. This gives us, typically might be 50 to 60%. And basic principles would tell us that production load factor is always going to be greater than 0. A high production load factor means that the equipment is being left on during non-operational hours. A low production load factor indicates a plant with large spikes in peak demand. And a production load factor of 1 indicates a plant with neither problem or both problems. So in other words, when we take our production load factor and our electrical load factor, it's fairly simple to use both pieces of information to narrow down exactly what is the problem. 15-minute data also offers unique insight. So this is much more valuable if you can get a hold of it from your provider. A 15-minute data such as the one shown here shows that there are cost-saving opportunities that can be identified simply from visual inspection. So not only can we tell what the production schedule of this facility is in terms of typically 4 days a week, but we can see that on weekends their power usage is about 1 megawatt, and that during non-production hours during the nighttime it's about 2 megawatts. And then so what we can see from this is there might be opportunities for turning off equipment during non-production hours. We can also look at this and compare this. We can also look at the non-production hours and say, okay, there's a megawatt of energy being used. What is using that megawatt? What equipment? And is there any of that that could be turned off? It also helps us identify any aberrant demand spikes, and if those, and we can discuss whether those could be avoided. Power factor is something also you may find on your bills. It's important to pay attention to this if you can. This is caused by motors or other inductive type loads where some of the power that's being drawn or provided from your utility is going towards energizing the magnetic fields, whereas the power that you're actually extracting from that motor is going to be in terms of real power or mechanical power. So in other words, the utility is providing the power as noted here in red, the apparent power in kilovolt amps. The real power is the power energy you're getting from your motor to do mechanical work. The blue is the reactive power used to energize the magnetic coils. Now, because the utilities have to provide more than what you're actually using to do your work, they are going to penalize you in the form of a power factor penalty. This may be implicit, it may be explicit, but this is something to pay attention to because this is correctable with the installation of capacitor banks that counteract the inductive load of these motors. And so if you are operating in it with a utility such as Houston, Texas, where the utility there bills directly on kilovolt amps, you absolutely want to be using capacitors to correct for power factor to get that as close to the real power as possible. If you're in another area where they're penalizing you below some threshold, you're going to want to install capacitor banks that bring you up to that threshold. This is typically a very effective cost savings measure. Paybacks typically are approximately 2 years, and there are many providers out there that will install this equipment for you and give you a good high quality quote for what exactly you would save for your facility. Now, let's talk about a few specific cost saving opportunities. First of all, we'll need to talk a little bit about sales tax abatement and avoiding late fees. We've just mentioned power factor correction. We'll also want to mention changing your rate tariff. Like your cell phone plan, sometimes you're not getting the best deal for the way that you use your energy. So it's always good to go back and look at what other rate plans may be available from your utility. We'll also talk about peak demand shifting. We've already mentioned the problem that ratchet clauses pose. And we'll talk about turning off equipment during non-production hours, and demand response programs that you may wish to participate in. But let's start with sales tax. In the state of Texas and most other states, as you'll see, there is an exemption for paying sales tax on the energy that is being used for manufacturing. Now, you're going to want to go to your state and find out exactly what the policies are, but this is fairly common in many states. And if sales tax is present on the bill, then the thing to do is to contract with a professional engineering firm that will conduct a predominant use study, which will then certify what percentage of your energy is being used for manufacturing. And that includes lights and air conditioning. If it's being used for the manufacturing space, that typically counts. And then you take this report, this predominant use study, you file it with your utility, and that utility will then omit sales tax from your bills from then on. You're also allowed to request reimbursement of past taxes. Most years allow 3 years of reimbursement. Texas happens to allow 4 years of reimbursement of back taxes paid on utility bills. So this is definitely something you want to check on, because it's an easy way to avoid paying for something that you're not required to pay. As an example, this is a utility bill from a recent client where you can clearly see on their bill, their total energy bill comes out to be approximately $44,000, but $3,000 is sales tax in particular. So not only could they be avoiding paying $3,290 per month, but they can request a reimbursement for the past 4 years, which could be, if this month is typical, on the order of $158,000 in reimbursed tax. So this is definitely something you want to look at on your utility bills and avoid paying. Second, often large facilities, the utility bills are paid by corporate headquarters, or perhaps an accounting department that may be removed a bit from the plant manager and his office. So what can happen is occasionally a utility bill may be paid a little bit late, even a day or two late. But then if your utility charges you a late fee, essentially you're taking out a short-term loan. And for the plant manager, even if this may not be directly under your responsibility, essentially a plant manager, this is going to come into play in her budget for the year in some form. And so this is something you want to be aware of, is are your bills being paid on time or not? For example, this is a former client who was charged a 10% late fee by the utility for paying their bill a few days late. Now, that may not sound like much, but that's equivalent to taking out a short-term loan. And if you did this repeatedly, if you just paid your bill each month a few days late, essentially you'd be borrowing that $25,000 loan for a few days each month at an APR of 120%. And so this can be quite significant and can impact any plant manager's budget. And so you certainly want to be aware of this. Ratchet clauses are also something to be aware of. This is an example of an electrical meter where there was a separate electrical meter simply for some external security lights and a backup air compressor. And what you clearly can see is in the months where they went and tested or used their backup air compressor, their demand was quite high. It was around 300 or 350 kilowatts. But in the months where they didn't use the air compressor, they were just using external lights, their demand may have only been about 8 kilowatts. But yet their ratchet clause still charged them a considerable amount for demand because of the use and the peak use in past months. And so this is something where you should watch for this in your bills, because in other words, a peak demand spike can not only hurt you 1 month, it can hurt you for the next 12 months. And in a situation like this, it was much more cost effective to integrate 2 electrical meters where this spike in demand would have been unnoticeable among all the other equipment and would have not have triggered the ratchet clause. A case study and an example on how rescheduling equipment can save you money, even if you don't reduce your energy use, comes from an industrial paint thinner plant that we were at years ago. We identified a low electrical load factor, and this was indicating to us that there was an electrical peak problem. It took us almost a full day to finally figure out what was the peak problem. Because this was a paint thinner facility, you can imagine there was a lot of oil-based products that were being used across the plant. And so fire danger was a very significant thing. They had an extremely large fire suppression system, including a 100 horsepower pump for their fire suppression system. Now, they were required to test this weekly, and they were testing it at 3 to 4 p.m. when everything else in the facility was also at its peak load. So during their peak load period, they were adding an additional 100 horsepower to their monthly peak. So simply by shifting this testing to their hours where there was only a skeleton crew using the plant, did not change the energy they were using, but it shifted that monthly peak and saved them a considerable amount of money. Another example of this was an aluminum beverage can manufacturer. In looking at their utility bills, in particular, their demand doubled in November. And our lead student requested the 15-minute demand data and determined that this peak demand occurred on a Sunday in the early morning hours. And eventually, what was revealed was this is a situation where daylight savings time was causing a computer problem. When daylight in the fall, when the clocks are set back, typically we experience the hour of 1 a.m. twice. And what was happening was the electrical demand was getting stacked on top of each other because 1 a.m. was happening twice. And so this caused a huge spike in demand. And by contacting their utility provider, they were able to get those charges reversed, which saved them tens of thousands of dollars. And this is another reason why it's good to take a close look at your utility usage to see if there are opportunities for cost savings. Finally, this was a former client that made pet products. And in talking with the manufacturing team, they agreed that their production line could be paused without real negative impacts to product or product flow. And we invited their utility representative to be there with us on site. And that utility representative confirmed that there was a demand response program available to them. This is a program where the plant agrees that if they get a phone call that the grid is about to be overwhelmed, that they will reduce their usage by a predetermined amount. And for being willing to take that phone call, they get a monthly payment of $38 per kilowatt that they're willing to curtail if asked, if they're ever asked. And so in other words, if they're willing to reduce a megawatt off of their electric bill, or in other words, put most of their plant just into a standby mode for an hour or two, and if they're willing to do that a couple of times a year, they're going to receive a $38,000 payment from the utility just for being willing to do that. So demand response programs can be a great fit for a certain type of facility where pausing production or perhaps pausing a portion of your production for a time would not be disruptive to your overall facility goals. Now, we've talked a lot about electricity. Let's talk just a few minutes about natural gas usage. Reminders that sales tax abatement is also typically applicable to natural gas, as well as natural gas. When you purchase it, you can often, depending on your contract, you may be agreeing to a pre-purchase amount in exchange for a lower rate. But this means that you need to have accurate forecasts, because if you overestimate how much you're going to use, you're going to have to sell back the unused natural gas at a lower price. Or if you underestimate your usage, you're going to have to buy extra natural gas at the market price. And so a common occurrence is for a facility to sign a contract under a certain pre-purchased amount, and then over time the facility grows, and then they discover that they are consistently under or over predicting their use, and they're paying a much higher price than they wish. So updating your forecast, going back and updating your pre-purchase amount can be a significant cost savings for many people. Finally, water and wastewater costs can also be minimized. Most water utility bills are about 40 to 50% the cost of the utility providing water, and about 50 to 60% is the cost of the utility handling the wastewater. In other words, handling the water that goes down the sewage drain. And by default, they put a meter on the incoming stream and then assume that 80 to 90% of the water you bring into the facility goes down the drain. Well, if you're a facility where a lot of the water you use is evaporated off, say in a cooling tower, or if you're actually using water in your product, such as a beverage company or a soda company where they're actually putting water in cans and selling it, well, then you're paying for a lot of water that really isn't going down the drain. And so it can be worth installing a second meter on the wastewater stream to measure exactly how much is going down the sewer lines, so that you're only billed for what you're sending down. Many utilities also allow you to meter certain uses. So for example, you can meter the makeup water on a cooling tower, knowing that that's the same amount of water that's being evaporated off, and use that, and they'll deduct that from your incoming stream to figure out what your wastewater was. So if you're using water in a couple of places, you could also install meters on just those equipment. So if this webinar is intended to be just a fast overview of what opportunities are available and some of the things you should look for in your utility bills. If you're looking for more information, the Better Plans program has some nice instructional manuals about understanding your electricity and natural gas and water bills, as well as how to handle peak demand. I would also encourage you to consider using some of the more recent tools provided by the Department of Energy. The Energy Footprint tool in particular is an Excel sheet that's designed to help you track your energy usage. That tool is about to be replaced by another software known as Verify, which does everything that the Footprint tool does, plus it will help you do regression analysis to understand how much of your energy use is being used based off of your production levels, how much is due to weather fluctuations, and how much is your base load, which will help you identify more precisely opportunities to reduce your energy usage. There's also tools for managing your water use in particular. If you are a heavy user of water, or wastewater bills are high, this is something you should consider using as well. And finally, the Department of Energy also has a dynamic Sankey tool for manufacturing facilities, where they have aggregated data for manufacturers in different sectors and mapped what is the average amount of energy being used and in various places in your facility. This can be a great resource as you dive into your energy analysis to baseline your usage against industry averages in terms of where your energy is going, what equipment is using the largest energy, and may help you identify places where you are outside the norm, either for the better or opportunities for improvement. So with that, I'd be happy to take any questions. But as always, this webinar will be posted on our website, and we would always welcome questions or like to engage with you through email. We can talk to you, we'd be happy to talk to you about some of the other free services that we provide to manufacturers, and commercial buildings throughout our service area. So with that, thank you for your attendance, and a reminder to join us next month when we'll be talking about how to conduct your own energy assessment internally and identify opportunities not just to reduce costs like we talked about today, but also to reduce costs and your energy usage.